In this segment of Mrs. M's Math to the Masses, in a minute or two, we're going to talk about distance and the way you can solve for the length of a segment given two coordinates. There's three different ways. So there's always the formula we can plug into. There's a T-chart method to avoid working with negatives where they can go so wrong in the formula. And then there's a way to do it just on a coordinate grid. This is what the segment would look like if we plotted the points run 4, rise 7, run 0, rise 4. Let's come over and do it the longest way first. Here are the points written again. You randomly have to call one of the points point 1 and the other one point 2. It doesn't matter which is which as long as you're consistent with how you put it in the formula. So let's call this first one here x1, y1, and call this one x2, y2. Let's rewrite the skeleton of the whole equation, everything that's there before we put in our coordinates. Remember, it has minus signs inside the parenthesis. Now, our x2, y2 lead both, so let's substitute the 0 and the 4 in first. And then let's put our x1, y1 in appropriately. You can pause right now and double check that you like the way I substituted that. So the next step, 0 minus 4 is negative 4. Just go to neutral color. It'll be squared and added to 4 minus 7 is negative 3. That will give you 16 plus 9 equals square root of 25. And your answer is 5. When you got here, if you know your Pythagorean triples, you would have seen 3, 4, 5. You would have known the answer already. Now let's try the T-chart method where you just copy over the coordinates of the 2 points. There's the first one. And this one, we're going to avoid working with a lot of things over here and get the same answer. So I need you to think about how far apart 7 is from 4. What would you do to get from 7 to 4? You would subtract 3. And how would you get from 4 to 0? You would subtract 4, because that's all that's happening here in the formula. You're finding out the difference between the two values. At this point, we're going to completely ignore the negatives because we're finding the distance of a line, and a length is always positive. But what we are going to do is go substitute into Pythagorean theorem because it is derived from the distance formula. We're going to call this number our A, this number our B, and we're solving for C, the length of our segment. And again, I said we're going to ignore the negative signs. So I'm going to do 4 squared plus 3 squared. I can ignore it because this is going to be the length, and length is always a positive value. Now we don't want C squared, we want C. What is the opposite of a square? It's a square root, and that will cancel out and give you just C. But the rules of algebra say whatever you do to one side of the equal sign, you must do to the other. And now I want you to look at this here and compare it to this up here. The exact same thing is happening. So we end up with square root of 16 plus 9, which is square root of 25, which equals 5. There's one more way I want to show you. If you have the privilege of having a coordinate plane near you and you're looking at it, we can always count horizontal distance. So I can go from this x on the left to this x on the right. It is 1, 2, 3, 4 units of length. Likewise, from this y value up here to the y value down here, it is 3 units of length. And that means, let's see if I can push this up, I can go 3 squared plus 4 squared equals c squared, and I would get the same answer. I also want you to remember, if you've listened to the silly song I have from the geometry teacher I think is amazing in Colorado, because I like anyone who can do music, he says 3, 4, 5. I caught a fish alive. 3, 4, 5 is always a Pythagorean triple. 3 ways to solve.